5.3 Properties of Logarithms. We're first going to look at doing a change of base. Most calculators have only two types of log keys, one for the common logarithms, base 10, and one for natural logarithms, base e. Although common logarithms and natural logs are the most frequently used, we occasionally need to evaluate logs with other bases. So to do this, we need the change base formula. Here's what the change of base formula shows. And you'll want to write this down. Let a, b, x be positive real numbers, a doesn't equal 1, b doesn't equal 1, and log base s can be converted to different bases. So here's how you set it up. You look at what you were given, and you do log of the x over log of your base, which is base a, in a base that you know. We call that b. Or, take for example, log base a. You notice we just did log x over log a with the base 10 that we knew, making it easier to punch in our calculator and evaluate. Maybe your favorite one is base e. So again, we have this log base a of x. You do log of the bigger number, or natural log of the bigger number, over natural log of the base. And this gives you the answer. Now, no matter what you choose between base e or base 10, because these would be probably two that we use, you will still get the same answer. Yes, log of x will be different than ln of x, and log of a will be different than ln of a, but overall the final answer you get will be the same when you divide them. One way to look at the change of base formula is that logarithms with the base a are simply constant multiples of logarithms with base b. The constant multiplier is 1 over log base b of a. So let's notice here. If I have log base 4 of 25, I'm going to use base 10. I would do log of 25 over log of 4. Equivalently, it looks something like this, just to help you out to see what numbers you would get. And then when you divide it, you get 2.3219. The same can be true if you want to use natural logs. Say you want to do ln of 25 over ln of 4. Now, if you're just kind of writing it down to follow through, this step would look different, but in the end, you would still get 2.3219 if you went around to 4 decimal places. Here's what I recommend. Don't round until you're completely done with the problem. So if that means you need to type in your calculator ln 25, enter, and get that number, and then hit your division sign and do open parentheses, ln of 4, close parentheses, and enter, then I'll take the whole value of ln 25 and divide by the whole value of ln 4, and so then you would get the correct answer without being off by decimal points. The same can be true for the next one, log base 2 of 12. If you want to, you could do ln 12 divide by ln 2. This step would look different, but your final answer would be the same. So again, practice with your calculator so you can understand if you're getting the correct value, so you do not get frustrated when you get to the homework by a calculator error. Now let's put to use some properties of logarithms. So we know that logarithmic function with the base a is the inverse function of an exponential. So it makes sense that the properties of exponents should have corresponding properties involving logarithms. For instance, the exponential property a to the 0 equals 1 has the same corresponding log property of log 1 being 0. And we looked at this in a previous section when we listed out the 4 to 5 different properties. So if we want to look at the properties of logarithms, we could do something called expanding and condensing. We can take a logarithm of base a, or even a natural log, and if it has multiplication between what I'm logging, I can separate it into addition. Again, if I have multiplication and what I'm taking the natural log of, I can separate it into addition and write natural log more than once. If I'm dividing, I can separate it by a minus sign. And if I have a power, I can bring it out front to have n of that log. Now this is what we're going to use when we're asked to expand or condense a function. For instance, it says write each logarithm in terms of ln 2 or ln 3. So we're going to expand it out and use what we can with it. So say for instance we take ln 6. Well, it says in terms of ln 2 and ln 3. First I'm going to try and get 6 in terms of 2 and 3. So ln of 2 times 3. Because they're multiplication between these two, I can separate it and write ln more than once. ln2 plus ln3. Final answer. Now ln2 over 27, the first thing I would want to do is apply the quotient property and separate it out. Because it's division, I'm just going to put a subtraction sign between them. And notice I did not say ln2 minus 27. We did ln2 minus ln of 27. Let's work with 27 because this is already in a base ln of 2. 27, how could I relate it to 2 or 3? Well, since 27 is odd, we can't relate it to the 2, but I could relate it to 3, and it's the same thing as 3 cubed. Then the very last property is you can take exponents, you can pull them out front. Only in front of the logarithm you're working with, and notice I can put a 3 here. Not all the way in front of the whole problem. And so then this would be your final answer. So let's look at rewriting some logarithmic expressions and working more with these properties. So the properties of logarithms are useful for rewriting in forms that simplify the operations of algebra. So this is true because these properties convert complicated products, quotients, exponential forms into simpler sums, differences, and products. So let's start here. I want to expand this first one. Well, the first thing you're going to do is see if you can separate it by addition or subtraction. And what I mean by that is the fact that this thing is being multiplied together, so I'm going to separate it out by addition, and I'm going to separate each thing that's being multiplied. So log base 4 of 5 plus the x cubed plus the y. Notice they all have the same bases. That's the only reason this property works. And I write log each time. Then the final step I can look at is look at each individual term and see if I can do anything. So log base 4 of 5, I can't do anything. Log base 4 of x cubed, I can take this exponent and I can pull it out front. Now when you pull it out front, it just makes it a large coefficient. And then log base 4 of y, I can't do anything with either, so this would be my final answer. Now in this one, what I want to do is I want to first, like I did before, separate out any multiplication or division. And so since this whole thing is being divided, I'm going to separate it out by a minus sign. Now you'll see here that they went ahead and took the square root and rewrote it as a 1/2. I would have done the same. You rewrite it as a 1/2 minus the ln of 7. So then the only step you have left is to take this 1/2 and to pull it out front. Now if you had not seen that, you would have been looking at this. Then you would have had to say, let me write that as a 1/2 power, and then bring it out front to end up with the same answer that they did. Now here's the deal. Notice that we did not do anything with 3x minus 5. We only have a power property, a quotient property, and a product property. We don't have something taking subtraction or addition and changing it. So be careful and don't overwork it. Now you're going to have multiple of these expanding and condensing in the section. If you need any assistance, please let me know. And I hope this helps with this section.